My name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 771. Please turn to it, page 771, and today is our lesson number 93. On page 771 you find what are known as graded questions. There are 10 of them. The first two that you see on the first page, on page number 771, they are easy. The next 4 on the following page are medium, and the last 4 appear on the last page. Those are hard. On a scale of 1 to 10, number 9 is just 1. And here's the question. We are told rather, that 2 times x minus 3 equals 8. Question is, how much is x minus 3 over x plus 3? Let's find out. We have to figure out the value of x. Let's divide both sides by 2. And if we do that, the 2 drops out, and x minus 3, we are told, equals 4. Add 3 to both sides, and we find that x equals, 3 drops out, x equals 7. That's it. We put it back in here. X minus 3 would be x minus 3 over x plus 3. X minus 3 would be 7 minus 3 over 7 plus 3. 7 minus 3 is 4. 7 plus 3 is 10. It's just 4 over 10 is the answer. Now it's up to you. You can grade in this answer as 4/10, and it will be accepted. It's a perfectly legitimate answer, and the computer will accept it. 4/10, because they give you four spaces to put in your answer in the grade-in sheet. It's my accent, you understand, sometimes. And there are 4 spots that they give you, and this will fit perfectly. You can leave it the way it is, or if you like, you can reduce it and you can grade in as 2/5, or if you like, you can grade in as 0.4. But I do not recommend grading in decimal because it's annoying. Oh, besides, you could not have, I made a mistake, you could not have graded in 0.4 because they don't give you the room to put a 0 in the first spot, so it would have to be 0.4. But don't do the decimal. As I said, don't mess with the decimal. If your answer turns out to be fraction, leave it the way it is, and if it's too large in terms of number of spaces, then reduce it. Here, this is what I would grade in. I would not bother with anything at all. Why should I waste my time? Just grade in 4/10, that's it. But on the other hand, if the answer turns out to be 14/10, obviously you can't grade it in because that requires 5 spaces. They only give you 4 spaces. So here we have no choice but to reduce it as 7/5. Otherwise I wouldn't bother with it. Number 2. So sometimes you end up making some careless, silly mistakes when you try to convert the fraction into decimal, because there are nitty-gritty rules that you have to follow in order for the computer to accept your decimal answer. And those rules are very annoying. Let's do number 2. Number 10 rather. It says, when twice a number, let's call it x, is decreased by 3, so we have to subtract 3 from it. You see, when twice a number is decreased by 3, the result is, that's the equal sign, 253. One more time. When 2 times some number is reduced by 3, if you're reducing something by 3, decreasing something by 3, we're subtracting 3 from the result. So if twice a number is reduced by 3, the result is, which is the equal sign, 253. What are they asking? What is the number? Let's just solve for it. So add 3 to both sides. 3 drops out, and we end up 2x equals 256. And therefore x will equal 256 over 2. And all we have to do is divide the number by 2. That's all. How many 2's in a 2? 2 has only 1 2. How many 2's in a 5? 5 has 2 2's. The remaining one goes and joins this guy, becomes 16. How many 2's in a 16? 16 has 8 2's. There you go, that's our answer, 128. Let's go on then to the next page, problem number 11. Problem number 11. And like I said, the previous page, the first page, two problems appear on the first page always for the grading question. Those are easy questions. On the following page you will see 4 questions, those are medium, and on the last page you will have 4 more questions which are hard questions. So now we are getting into the medium territory. Page number 772. So gradually they're going to get a little prickly, you understand? We are given a table here, white, black and total, and we are told high tops. We are told high tops, low tops, and again total. 3600, this is empty, this is empty, this is empty, 1500 and 5500, and then 10,000. This is empty and this is empty. Let's see what they're asking. Outdoor sneaker company, very catchy name. Outdoor sneaker, well that's what you get if you go to fancy marketing school, you see. Manufactures only white sneakers and black sneakers. Well, good for them. White and black, there you go. Both of which are available is either high top or low top. Alright, right there. On the basis of the information in the table above, how many black sneakers did the company manufacture? Alright, how many black sneakers? Well, let's find out. Right here is the black, this is what we want to find out, but we cannot find out this number. We cannot find out this number. In order to figure out the total black number, we want to find out how many black sneakers were manufactured. Eventually what we want to find out is this guy. But we cannot find out that guy. We cannot find out that guy until we know this guy. And we cannot figure out how many high top black shoes are manufactured until we know how many total we have. So let's start from here. So 10,000 minus 55. 10,000 minus 5,000 would be 5,000, so this is 4,500. So they had a total of 4,500. They had a total of 4,500 high top, and we are told they had 3,600 white high top. I'm making it too much fuss here, so let's subtract 36 from it, and that gives us 900. So that 900 goes in here. That 900 goes in here. That's it, we are done. So how many total black did they have? 900 plus 1500. 1000 plus 1500 would have been 2500, so it's 2400 is the answer. 2400. 2400 is what you want to grade in. That's all. It's just a matter of paying attention. It's not a difficult problem. Just pay attention and make sure that you do what they're asking here and you don't mix up the numbers. That's all it is. Number 12. We're done with this one. Number 12. If you get a chance later on, I would like you to compare problem number 12 that we're about to do with this question. I would like you to compare it with number 18, which is the hardest problem, the most difficult problem that appears in this section because it's the very last one of the grading question. So previously a similar question appeared as a very hard question. Here it's appearing as a medium question, but it's a similar concept. It's a very similar concept, which is why obviously I want you to compare it with. Number 18 on page number 530, something that we covered on, I should have written down the day number when we did, number 18 on 530, on 520, and I don't have the day written down. What do you know? Or day 40. Day 40. This one came from exam number 3. Compare the two problems. We will do this one and then watch the other video and see if you can see the similarity between the two as to how they would take a very same concept and convert it into a medium question, and again take the very same thing and present it to you as a hard question. As I said before, it appeared in number 18, the most difficult question. Here this is straightforward medium question. Here's the picture. In the picture above, PQRS is a rectangle, so we have to actually draw it as a rectangle, and I did not do a very good job as presenting it as a rectangle because I made it too wide. There. Now we can show it as a rectangle. There. I hope it looks like a rectangle to you. Okay. PQ R S PQRS we are told is a rectangle. It's not a square. Point Q and R lie on the graph. Point Q, as you can see, point Q and R lie on this graph here. And the equation of the graph, of course, is y equals ax squared. Y equals ax squared. What the hell is it? Where is it going with it? Where a is a constant, alright. If the perimeter of PQR is 10, what's the value of a? Alright. So we know the perimeter of PQR is 10. What else? They must have told us something else. There you go. We told that P is -1, 0, and S is +1, 0. Which tells us that P to S is 2. And since the perimeter is 10 of this thing, and one side is equal to 2, P to S is 2, and of course that means Q to R is 2. So 2 plus 2 is 4, that leaves us with 6, which implies that Q to P plus R to S must equal 6. That in return implies that R to S must equal 3. You with me? Must equal 3. Obviously, from here to here it would have to be 3, because 3 plus 3, RS, which is 3 plus 3 is 6, 6 plus 2, P to S is 2, 6 plus 2 is 8, plus 2 is 10, which is the perimeter of this rectangle. That's it. We're almost there. So now that we know this is 3, we can figure out the coordinates of point R. We have to find out either the coordinates of point R or the coordinates of point Q. Once we have the coordinates of one of these 2 points, either Q or R, we can put it back in this equation here, because this parabola goes through these 2 points, and once we have the coordinates of the points, we can plug them in this equation, because this equation has to be satisfied for those given coordinates of points Q or point R, because it goes through those 2 points. And once we substitute the coordinates of a given point in this equation, we can solve for A, which is the constant. So let's do that. So what are the coordinates of R? Well, the x coordinate would have to be the same as the x coordinate of S, which is 1. X coordinate of R would have to be the same as the x coordinate of S, which is 1. I don't know why I had this uncontrollable urge to put down +1. Of course it's +1, it's on the positive side. And the y coordinate we just found out is 3. It's 1, 3. So these coordinates, this equation must satisfy. This equation must be satisfied when we substitute these coordinates for x and y. Let's do it. I'm going to continue here. I need the room, so we need to erase all of this thing. So y is equal to 3 when x is equal to 1. A times 1 squared. It can't be this simple, can it? Apparently it is. 1 squared is just 1, therefore A equals 3. Done. Voila, that's it. We're done. The question was, what's the value of A? The answer is A is 3. At this point, as I said, it's a good idea to go to page number 530 if you have not watched that video already, or if you watched it a little while ago and if you don't remember it, which is even better. What I want you to do at this point is, after having watched this video, turn to page number 530 and try to do that problem yourself first, and then watch that video, day number 40, and then compare the work together. Do you understand? Number 13. We're done with this one? Number 13. Problem number 13. It says A times B plus B equals A plus 2 times C. What's the value of B when A equals 2 and C equals 3? What's the value of B? Alright. Just put it in. A equals 2. So put it in here. 2 times B plus B. And we are told that C equals 3. put it in here, a plus 2 times 3. And a, of course, beats 2. I'm not paying attention here. A, we are told, is 2. Actually, this is simple, much simpler than I expected. I don't know why I always want to expect a complicated thing. It's very simple. It's just 2 times 3 plus 2, which is 2 times 3 is 6, 6 plus 2 is 8, and it's 2b plus b, so that's 3b. That's just 3b. 2b plus 1b is 3b. So if 3b equals 8, divide both sides by 3 and we're done. Which means b equals 8 over 3. That's it. That's your answer. b equals 8 over 3. Number 14. Number 14. We are given two parallel lines. We are told that these are line M and line N. Then we have a line L that goes something like this and a line K that's steeper. This is Y, this is X. Point A is somewhere on K, right here is point A, and point B is right here. Alright, let's see what they're asking. I think that's about it, and they also give us point C. I don't know if there is any use for that. In the picture above, M and N are parallel, as we can clearly see. Line M here, is parallel to line N. We can clearly see that M is parallel to N. Alright. And L bisects triangle ABC. Ah, that's why we need that C. So here's your triangle. This is the triangle, not triangle rather, the angle. Angle ABC, ABC. In other words, this angle that you see there, L, line L, cuts it in half. Line L cuts the angle ABC in half. That's what it means to bisect. Alright, so far so good. Which means this angle, these two angles are equal to each other. Okay, this is where the prickly part is going to come in. Pay attention. We are told, and try to learn to read it in plain English language. Don't read it like a freak. Don't read it like a geek, like a nerd. People will sit there and say 45 is less than y, which is less than 55. What the hell does it mean? Read it in English language. So let's continue then. In the picture above, M is parallel to M, we are told. Line L cuts the line L cuts the angle ABC in half. And then they go on to say that Y is between 45 and 55. That's how you read it. Y, angle Y that we're told here, right here, Y is between 45 and 55. Is between 45 and 55. The suspense is killing me. What the hell do they want? What is one possible value of x? Oh, for crying out loud. One possible value of x. Where is x? Oh, right here is the x. Now, here's what's going on, okay? This is classified as a medium question. I'm going to erase the thing. I need the room here. I want to redraw this thing. This angle x that you see is the same as one of these two angles, okay? I want you to compare this angle right here with this angle here. What's going on here is, here's your line M. Here's our line M and here's your line N. And this is line L. This angle that you see there, let's give it a name here. I'm going to call it, what should we call it? Well, this is also X. You see this and this are equal to each other. This is line, this angle and this angle are the same. And of course we have one more here which goes like this, but this is also X because of the fact that A, B, C is cut in half. But we are not interested in the other part. We are just interested in the fact that this angle is same as X. Okay? And we are told that Y is between 45 and 55. Y is between 45 and 55. And what is Y equal to? Y is the same logic. Let's put it here. I'm going to show you the Y part here on the bottom. Here's our Y, and this Y is same as this Y, which is being cut into half. In other words, Y equals 2 times X. And we are told that Y is between 45 and 55. The question simply is, what is one possible value of X? So if Y is between, if y is between 45 and 55, pick a value for y. And what better value than 50, because 50 is right in the middle. Let y be 50. Let y equal 50. If y equals 50, and we just found out that angle y is 2 times angle x, because angle y is same as this angle y, which is being cut into 2 halves, x and x. So therefore, if y equals 50, and since y equals 2 times x, therefore x must be 50 over 2 or 25. That's it, you're done. They're looking for one possible value of x, and we just found it. Now if you wanted to find a complete answer, just for theoretical purposes, for learning purposes, then the complete answer would be this. Complete answer would be this. If y is between 45 and 55, then x would have to be between half of 45 and half of 55. Any value that you grade in between 45, half of 45 and half of 55 will be accepted. In other words, x is between 22.5 and 27.5. So if you grade in 27 or 27.4 or 27.49, they will accept it. But why make your life miserable? Just pick 50, and half of 50 is 25. Just grade that in. But for theoretical purposes, any answer choice between 22.5 and 27.5 is perfectly legitimate. You understand? I will see you tomorrow, okay? Bye now.